How y'all doing? I'm Shub. I help lead solutions engineering at arcade.dev. Most of my work is directly with our customers who are in the enterprise. We work primarily at Arcade with folks in the banking space as well as in the pharmaceutical space. So everything I've put together today is from the learnings that I've had deploying AI agents and especially secure MCP servers into the field. With that, we're going to be taking the next 30 minutes to actually build out all of those primitives that all of the speakers today have spoken about. You've already used Gemini CLI, you're already started vibe coding your applications. Now we want to give those applications, those agents, access to all of the things that it actually might need to do on your behalf. We're going to play around with some fun primitives. We're going to try to see if we can fool an LLM with prompt injection through tools, and try to cover much of the process that the last speaker just spoke about. So with that, I don't love slides because it makes me go from one thing to another too quickly. So what I'll do is I will give you all access to, if this loads, there we go. I'll give you all access to this GitHub repo. This is built for this workshop. It has all of the slides, everything I'm going to talk about. You can take it home with you. You can use this as a foundation as you build out secure MCP servers to give your agents access. I'm going to give folks a second to grab that. And I'll go directly over to the repo itself. So in the repo, you'll find the files, but then there's this humongous README, and it explains exactly what we're going to be doing today. So given that you've spent all day working on building agents, vibe coding, learning about tool calling, why security matters, we're going to put all of that together, right? We're going to start off building a secure MCP server using Arcade Secure MCP Framework. And then at that point, we'll have 5 production-ready quality tools. But that next hop is, OK, I've got 5 tools, but I need my agent to do a lot more. And that's where all of Arcade's tools come in. And here it says 20+ production toolkits. It's more like 1,000. That's my bad. I was doing this right before I hopped on the stage. But our goal really is to tackle that toxic flow triangle that you've been hearing so much about at Snyk, right? So you've got these untrusted instructions. You might have prompt injections, sensitive data getting leaked, like your API keys and passwords, and then exfiltration paths that might be just open to these agents to grab those secrets from you. So traditionally, you might have added your API key directly as a parameter in your tool. That's a no-go. You should never do that. You might have asked your client to pass that API key directly in that call. Again, for both of these, the API key is in the protocol. It's within the MCP protocol, right? It's getting passed over that HTTP SSE stream, and it's getting logged. It's cached. It's visible to the LLM. 2 things that we do not want in this whole thing, because prompt injections can extract those credentials, and you're not keeping to the multi-tenancy, multi-user application types that we've been building for so long. I don't go into Google and see someone else's Google Drive folders. So why should I do the same if I'm building an AI agent, right? So that's like the whole premise of building with Arcade, where we do not have the client nor the MCP server itself in the function definition have the tokens, the secrets, anything that should not be at the LLM or at the client side should, we make sure that we inject it during runtime. So this helps alleviate these factors 2 and 3, which is really good. And you can't exfiltrate what isn't even there, right? And it helps with multi-tenancy, where each user can use their own tokens, their own services to get access. Now, here is the total architecture of what we're going to be building today. The MCP client that you all have been using all day today is the Gemini CLI. Now, most MCP servers that are built will work with any MCP client. Arcade today will work with any MCP client. Gemini CLI is just one of those clients. You can add this into Cursor, VS Code, Claude Code, OpenAI. You can add this into ChatGPT. What happens at the server itself, this is where your tools live. You've got the MCP protocol handler that receives that tool request from the AI agent or the MCP client and says, hey, I need to do this action, like send an email. To do that, to send an email, you need access. You need a token from the user. It shouldn't happen at the protocol layer. Arcade will inject it into context. Context is an MCP-specific word that I'm going to be using today, and I'll get more into what context is. But you pass that directly into context for the tool during runtime, and then post tool call, return that back to the MCP client, to the LLM, so that it's able to reason and act on whatever tool response is received. So the credentials are never injected after the protocol, before or during the protocol layer. It's only after the protocol layer. The LLM never sees them, so you can't leak them. You can't do exfiltration. But the key point here is that the only way to really solve this is you need an agnostic third-party layer, middleware, that sits between the two, your client and the MCP server, that's able to inject and hold these auth tokens and secrets so that neither the client nor the MCP server has access to them, because that's where you add in the risks of exfiltration and all of the other foundations that we see today. Now, given all of this, I've seen a lot of demos. I've seen a lot of workshops. I've heard some of the questions that came out from the crowd today, and it was about tools for LLMs, right? So an AI agent is basically a really good prompt and a set of tools. Now, both of those things need to be good for the AI agent that you're using to be good. Let's talk about the tools, because I'm building an MCP server. These tools you give to an AI agent cannot be the same tools that you as a human use. They have to be action-specific. They have to be intent-specific, because that's what LLMs are for, right? They're friendly, they're secure, they're intent-specific. You need to specify to it, these are the tasks that I want to accomplish before it really understands what it does. Now, the problem with traditional API wrappers is you've got a function definition where it says, OK, get my GitHub files, but my API, the GitHub API requires owner, repo, path, your access token, any references, and then it builds all of those like HTTP semantics, and it builds that API request to call the GitHub API. This is a no-go, because an LLM has to go through a human process or a declarative process to know exactly how to fill this in. What's much better is intent-specific, and this is what a MCP tool looks like. This is across the board, not just for Arcade's MCP server framework, but if you use other frameworks as well. You define a tool. This is the special thing here with Arcade is you can give that tool decorator specific parameters like requires auth or requires secrets and things like that before the tool is even executed. And then within the tool itself, you just define the parameters, like this is the repo, and then you tell it exactly what that repo parameter needs. It needs the repository name and the file path, and then you tell it that this is the exact file I want you to fetch, and then you define exactly what that tool does. So the LLM now knows this is what the tool does, this is the name of the tool, these are the parameters that I have to fill in. That is an LLM's only job in calling a tool. It is to pick the correct tool and then fill in the parameters. That's it. All right, now that I've got that out of the way, let's get this workshop set up. It should be very, very simple. Once you're on this repo, go ahead, clone it onto your machine. And I'm using UV here as my package manager. You can do any, if you're using pip, feel free. But if you'd like to use UV, that would be great too. Now, once you've gotten to the repo, let's start up your terminal. We're going to be starting off by building from fresh an MCP server. The repo itself gives you an example MCP server, but what we'll do is first we'll install Arcade's server framework. So we'll UV, it's not tool, it should be UV pip install arcade-mcp. Oh, I haven't even started my virtual environment. So before you do that, start your virtual environment. You can use UV venv and then activate it. And then UV pip install arcade-mcp. Great. There is another piece I need. I also need to install a HTTPX dependency. But before I do that, what I can do right away is, now that I've got all of the Arcade packages, I can type in arcade new, and then I'll call this sneak workshop. And the Arcade MCP server framework will automatically fill in these example templates of tools that I can build with. Now, you all have Gemini CLI, which is a coding agent, on your laptop. What's really cool about this is now you can give Gemini access to this MCP server, turn on the MCP server, tell Gemini that, hey, you have access to the tools that are in the server that you can not only test live, but also edit while you're doing it, which is very meta, I know, but it's super cool. And here's a quick introduction to the tools that you get access to. The first is a very simple greet tool, right? It has no requirements. There's no requires secrets, no requires auth, none of that. It just will greet you by your name. The second tool does require a secret, and that secret is something that has to be on your machine and or passed, that is available to the MCP server before it can execute the tool. If it does not have that secret, it will not execute the tool. So you can think of this as like protecting resources that might be valuable. And then lastly, you have requires auth. Right now, requires auth is equal to Reddit. Out of the box, Arcade supports about, I think, like 20 different OAuth providers that you can just plug in. So you can type in requires auth Google, requires auth Microsoft, and so on. And if you want to define your own, all you would have to do is type in OAuth 2. Now, to take advantage of this middleware and make sure that these tokens are received and then injected during runtime, you'll have to first log into Arcade. So because you have the Arcade CLI, the next thing you'll do is Arcade login. And it will pop up. It will splash a sign-in page, and you'll sign in, and the CLI will automatically transact with our cloud to get back your API key for the CLI itself. So go ahead, do that. And this will allow you to gain access to all of our OAuth providers directly from the cloud. Now, once you've done that, I'll install the next dependency that I need, right? I need HTTPX. And what we'll do is, instead of working directly off of this sample server that Arcade gave me, I want to up-level this a little bit, and I want to show you how I do that. And to do that, I'll start off by just keeping the first tool the same. And you also have another server.py directly in the repo that you just cloned. And it starts off again with this very simple greet tool. It has no requirements. It will just greet you and then say, hello, your name, and then welcome to the Sneak AI Security Summit. The second tool does require a secret. It requires a file access token before it will go and read a file on your machine. The third tool that we've got here it's very simple. Again, it does not require any secrets or any OAuth, but there's one special thing that we do here is we use MCP's context.log info, which allows this tool to log directly back to the server. So we'll be able to, on the server level, get an output of exactly what this tool is doing and exactly how it's analyzing, and we can add additional steps. And this context piece is very, very important, because if we look at all of the requires auth and the requires secret, they're all being passed through context. And that's what's very unique about Arcade's MCP server framework is we allow context to also mean the GitHub OAuth provider's token, secrets, anything that you might need to pass and checked before, like governance rules that you might want checked before the tool is executed. So going back, the fourth tool that we'll be taking a look at is a fetch GitHub code. It's grabbing the auth token from our GitHub OAuth provider. It has the parameters it needs. And then the next piece of this is I wrote a very simple, just a GitHub API call using the correct headers, give it the correct HTTP URL, and that's it. And it will go and grab the correct file for me. And then to bring it all together at the end, we're going to up-level this GitHub tool and turn it into a security audit workflow. So instead of just one tool call, what we're going to be practicing here is this thing called tool chaining that is allowed within the MCP protocol, which allows, we're going to keep those context log pieces, which will log as the MCP server is doing things. And then the next part of this is we're going to use context tools call raw, which will allow us to call other tools within the MCP server itself. So instead of it just being an AI agent LLM calling one tool, getting back a response, you've got this workflow that is an MCP tool that lives within your server. Now, I heard a question back while I was backstage about why do I have to point an LLM to an MCP server? Why can't the MCP tool just be LLM? You're onto something. So context here gives us logging, gives us tools, gives us secrets and auth, but it can also do other things. And you should take a look at the MCP spec, but it allows us to do this thing called sampling. It allows us to do prompt sharing. So with sampling, what we can do is the MCP server, which holds the tools, will be able to request the client, which is right now your Gemini CLI, to use its LLM that you are using to talk to the MCP server instead of it having an LLM itself. So you can think of this as us building out workflow chains where you manage the LLM completely. You have control over the whole, you can see all the traces, you can see everything that the LLM is doing because you own the LLM. It's not making external calls to an LLM from the tools itself, which is really cool. The reason I don't have sampling in here today is Gemini CLI doesn't support sampling, and this is something that you might see with a lot of different MCP clients and servers is because we've built out this protocol so quickly. MCP has been around since November of 2024. It's not even November of 2025 yet, and we've made so many different changes that the client and the servers, maintainers, haven't been able to keep up with the latest standards. So you'll see the use of multiple different standards across the field. So with that, yeah. You're talking about a LLM gateway, or you can use an API gateway. Before Arcade, I was at a company called ngrok and helping build out ngrok.ai. You should check out, it's exactly that. Quick shout out for those folks. So now that you've got this far, we've logged in, we've created, I've explained all of the tools. Let's start this server up. So what I'll do is, it needs a file access token to be in the environment. So what I'll do for now is I'll just give it a random demo file access token. I'll export that. And then I'll start up my MCP server and pass the HTTP because I want to use HTTP streamable, and it will start up. It'll start up on port 8000. The next thing I need to do is give Gemini access to my to my MCP server. So I'll just copy this Gemini MCP add. I'm going to call it sneak HTTP. I'm going to say the transport I want to use is HTTP. Here is the URL for it directly into Gemini. It will add it, and then I could do Gemini MCP list. And I'll see that that sneak HTTP MCP server that I just started has worked. So as a test, what we'll do, and if you don't want to use the CLI, you can also go directly to the settings.json file and add in the MCP server. So to test this, what I'll do is I'll just say, using that first tool, say hello to the workshop attendees. It will ask you for permission to use the tool. I'm going to say allow all tools from the server during this Gemini session. And it's gotten back the response, and it gives it right back to me. Amazing. That's just a connectivity test to make sure that you've got the MCP connection and the Gemini connection set up. Now let's move on. We're going to try to use that read file tool that we just had. We have to inject a secret directly into it. So what I'll do right away is I'll copy this, like read file, and then there is an examples direct folder in here that has a vulnerable code Python script that's just for it to read. I'm going to tell it to read it and use the tool. And it gets back this error from Arcade. This is expected. You all should have gotten this error. And this is part of Arcade's security at this level. Our MCP server is not authenticated. And on top of that, we're using HTTP, and we're not adding TLS or other types of security onto it. Arcade picks this up and says, no, I will not allow you to pass secrets this way. If you want to pass secrets, and you're going to do it locally like this, you have to use SDIO, which is the other transport layer for MCP, and go through that. So what we can do very easily is go down here. I'm going to stop my HTTP server. And I'm going to start, I got to make sure I'm in the right virtual environment. Oh, I don't know why I did that. That's on me. I redid my virtual environment. All right, and now I've started up with SDIO, and I have to give access to it over to Gemini as well. And to do that, what I'll do is I'll copy this MCP server piece. And if you've noticed, if Gemini is in the correct repo, in the working repo, it has added in the MCP server directly in there as well. And what I'll do is just come here and replace it. And I will give it access to my virtual environment's Python. Documents. Oh. Nice. All right, and we'll go check on Gemini here. And now you'll see that it's got that sneak SDIO server connected. And we're going to go back and run that exact same prompt that we had given it previously, which was read that vulnerable code file. Oh. Ah, yes. Oh, OK. We're going to tell it to not do that. Let's see what tools we have. So Gemini makes this really easy. It's called sneak_security. Yep. And then you'll give it access, just like we did before. And it pulled that file directly from my directory because it was able to access that secret. So what we'll do next here, what we'll do next that we got this SDIO working is let's go back, and we're going to go back to HTTP. It's going to make it a little bit easier for us. I'm just going to restart my HTTP server. Make sure Gemini's got access to it. Awesome. And the next tool we've got is analyzing that code security. So what we're going to do is we're going to pass to it directly a quick script to read over and use the analyze code security tool, and it'll use it flawlessly. The thing we're doing here is we want to make sure that it's responding to us in JSON. LLMs are really good and trained in doing that. And that's what our tool responds to in as well, so that's really cool. And we're using this context logging, which makes it really easy for us to see what's happening on the server side. Moving on from that, so like we've done secrets, we've checked files directly on my machine. We're going to move on to using OAuth, and that's where Arcade comes in. You need a service that will go out to GitHub and say, hey, I've got this user, they're authenticated with me, but I need you to give me a token for them to access specific services that are scoped correctly. So right here, I'm asking for the scope repo to be added on to that token when I receive it. So I'll use this, and what I'll ask it to do is fetch one of the documents that are available in this GitHub repo, which is a prompt injection. So if you take a look at, I'm just going to do it in my, I'm just going to do it in here. And it looks like a simple hello world tool, but in it has system overrides as well as a attention to the AI assistant to tell it to drop and like push out any secrets that it might have access to in API keys. And we're going to try to see if this works at all with Gemini. Ooh. Not sure what's happening there. Let's see. I don't think I'm using any. We're going to try again. And the LLM reasons over what I'm actually trying to do, and I'll say I'll allow all tools. It looks like it's still saying that I can't do this because I need to be an SDIO, which I can move over to. I think we may have made a change to our system for that, but I'll move over quickly in the time that I've got. Cool. And while that's running, what this is going to allow us to do is Arcade is going to return a GitHub URL for us to go through. And then once we are able to do that, if I'm having troubles with the LLM here, but once we're able to do that, it will have the token ready to inject. What I'll do for us to have more time here is I will connect our service here directly to my cursor model, and I'll say, cursor, can you connect to Arcade instead? And that in. Oh. Okay, I guess not. A really fun feature of Arcade is CLI is you can say Arcade configure cursor here, and it will automatically go out and, oh, I spelled configure wrong, and go out and configure my cursor MCP file to be correct with what I'm expecting. And it did that, which is really cool. And it's able to pick up that server, but I'm not running an SCIO, which is not great. And what this workshop will continue to walk through is that next piece, which is now that I've got this GitHub token, I pass it to my tools, I can chain multiple tools and say, hey, let's call that analyze code security tool that we made third, and so on and so forth. And you can bundle these together as primitives that you can give to your AI agent to not just make it one-on-one tool calls, but actually further extend out the full lifecycle. So like an LLM AI agent that you've got directly calls a full workflow and sets that up for you. This workshop will go all the way down into, now that I've built tools, I need to give it access to even more production tools and tools that we use at my enterprise. How do I do that? Arcade has already built out hundreds of toolkits. If you check out our dashboard, this is your governance place. This is where you'll manage all your secret, your OAuth apps, all of your thousands of tools. You will use this directly, and you can grab Arcade acts as an MCP server, so you can add that directly into any AI client you have as well, and go on from there. But to wrap it all up, you're already vibe coding, you're already building tools and adding them. We want to make sure that you do it securely. And with that, we've built out the primitive for Arcade and Arcade's gateway. Thank you all so much. I think that is my time.